In this final lesson for this week, where we really build a solid base for talking about functions, I'm going to look at homework 6, problem 19. So you'll notice here that this is also a piecewise defined function, and this one has 3 pieces. So f of x is 4 if the input is less than -2. F of x is x squared if the input is between -2 and 2. And the f of x is -x plus 6 if x is greater than 2. Okay, so let's go ahead and draw our axes. Okay. Now, in the homework, you're not going to be asked this, but I want to do it anyway. After we draw this, we're going to talk about domain and range. Okay, so pieces first. So you can see that there's one piece to the left of -2. So that piece is everything to the left of here. Then there's a second piece between -2 and 2. So that's this there. And then there's a third piece after 2. Now, some of you might actually find it helpful to write that this one here is piece 1. This one here is piece 2. And this here is piece 3. If you find that helpful, then do it. If you don't find it helpful, then don't. It's up to you where you land on that. Okay, so remember what we talked about next? Let's plot the points at the seams. So at -2, we have the top 2 pieces coming together. The top piece, the function outputs 4 no matter what you feed it. The middle piece, the function squares its inputs. So the top piece, 1, 2, 3, 4. So I'm going to put an empty point there. And so that's us looking at the top piece. And then the middle piece squares its input. So look what happens. If I take -2 and square it, it's a non-strict inequality. So whatever this point is, it's going to be filled in. Oh, but when you square -2, you also get 4. So this is our first example where the 2 pieces actually meet. Okay? We've had a lot of graphs with gaps in them. In the previous video, this one, there's actually not going to be a gap here. Okay, so let's see what we got. So to the left of to the left of -2, it's a constant function. So it's just going to put out 4 no matter what input you give it to the left of -2. Between -2 and 2, you've got the squaring function. Okay, so let's plot the other seam point, and then let's go ahead and graph that middle piece. So at 2, you are having the x squared and the -x plus 6 pieces butt up. When x is equal to 2, the function behaves like x squared. You'll notice that this is a non-strict inequality. If you take 2 and square it, you get +2. So you have a filled in point there from the x squared. Now, -x plus 6 is your last piece. We called it piece 3. And it starts at 2. But if you plug 2 into that, yes, that would be an empty point. But what happens if you plug 2 into -x plus 6? You get 4. So these 2 pieces butt up to each other also. So even though technically there's a filled in point and an empty point, you don't see them because they overlap. You just see the one filled in point. All right, now x squared is quadratic, so I hope you remember from our basics of graphing video that the shape that you're expecting to see here is a parabola. So let's plot a couple more points. So if x is 0, 0 squared is 1. For both 1 and -1, when you square them, you also get 1. And so you end up with a parabolic shape like so. Okay? And then lastly, -x plus 6, that's a linear shape. So since we already have the seam point at 2, we only need one other one. So let's try I don't know, when x is 4 or something. If x is 4 and I plug it into negative x plus 6, that becomes negative 4 plus 6, which is 2. So let's go ahead and connect those dots. So there that is. And again, this piece goes on forever, like so. All right, so let's talk about domain and range. Again, this is not something that you're asked to do in the problem, but I really want you all to get lots of exposure to working with domain and range from the graph. So look what we have here. As you're moving along the x-axis thinking about domain, are there any gaps in the graph? Are there any values of x for which there isn't a point on the graph? The answer is no. It just keeps on going. Now, we only drew the graph out to here, but remember, this graph extends onwards forever this way. So even though you don't see a point for x values here, they're there, we just didn't bother graphing the graph. All right, so the domain in this case is all real numbers. Okay, now let's think about the range. So again, maybe I should do this. Rather than stopping it here and putting an arrow, maybe I should make it clear that this piece goes on forever like that, and then put the arrows on it. So looking at the range, you see any y coordinate down here, there's all these points to the right. So we're fine. There's all of these y values have points on the graph that correspond to them. And everything is fine and dandy until you get here. There is at least one point whose y coordinate is 4. But there's nothing happening after here. There is no point on this graph with a y coordinate greater than 4. So the range of this function is everything up to and including 4. But the range stops at 4. So that's this problem. This is homework number 6, problem 19. Problem 20 is very similar to this. And then 21 and 22, you're given the graph and you're asked to figure out what is the equation. I'm kind of curious to see what you all will make of 21 and 22. I'm fine with them being a little challenging. I'm sort of anticipating them being problems that we talk about on Friday, but we'll see how it goes. And this is the last video that I'm going to make for you for this week. Have fun. Bye.